Here we have the Cadillac 331 V8 engine assembled as a short block, pistons and rods attached to the crank and running on the dynamic balancer. You can see that as we take the locks off, this table is completely free to float. So effectively, when the engine runs, it's spinning as if it's in free space. Photocell at this end picks up the RPM and a phase angle reference. As we take the locks off, it releases the motion. And if we look at the balancing instrument, we can have a difference of display between balance tolerance in gram millimeters and a respective phase angle, or the amount of weight that's actually needed at a respective position, or look at the actual movement. Here we're measuring microns. So with the clutch fitted at the back end of the engine, we've balanced it to a movement of less than 0.139 microns. If I alternate the display, that shows us it's a balance tolerance of 5.752 gram millimeters. And that relates to a weight correction of 0.0383 grams at 14 degrees at 150 millimeters radius. So, not a lot. In this way, the engine, the crankshaft is physically measuring the weight transfer from the rods and pistons directly to the crank. There are no compensating masses, calculations involved. It's a physical weight relationship measured by the crank. The most accurate balancing you'll get of a V engine. If I stop it, you'll see, if we look at the pistons, we've got plasticine on each piston crown representing respective ring weight. It really does make a difference. You've got to chase every gram on a piston and match it, because the crank sees half of that as rotating weight.